Something about the moon is raising questions. For nearly 10 years, scientists have been trying to explore it using advanced self-driving spacecraft. They've spent hundreds of millions of dollars developing a new wave of lunar landers. But despite all that time and money, what we mostly have to show is a growing collection of wrecked spacecraft scattered across the moon's surface. That's the issue, but a possible solution might come from an unexpected source. Let's rewind to the past. Back in 1967, NASA Surveyor 3 successfully landed on the moon. It was a robotic probe designed to help prepare for the Apollo missions. At the time, this machine was considered cutting edge, though by today's standards, it was using a computer about as powerful as a basic calculator. And the landing? Far from perfect. But fast forward to now, June 2025, when a Japanese spacecraft called Resilience attempted a moon landing. Nearly 60 years later, the technology has drastically improved. Resilience was equipped with advanced processors, microchips, and a laser scanner capable of measuring distances to the moon's surface down to tiny fractions of a millimeter. Yet, despite all of this, the mission failed. The lander slammed into the moon so hard that it created a 16-meter wide crater. The company behind the mission, iSpace, pointed fingers at the laser rangefinder. It was supposed to start tracking the moon's surface when the lander was still 3 kilometers high. But something went wrong. It didn't activate until the craft was just 900 meters from the ground, still falling at 66 meters per second. By the time the lander system realized what was happening and tried to slow down, it was already too late. One possible explanation is that the moon's surface was darker than expected, meaning the laser signals didn't bounce back properly. The lander's sensors got confused and thought it was still much higher up, so it delayed firing the landing engines. Ironically, NASA's Surveyor 3 ran into a very similar problem, just in reverse. Its radar system expected the moon's surface to be darker, but it turned out to be more reflective. That also threw off its readings. In Surveyor's case, it happened just a few meters from the ground. The computer only had to cut off the engine and let the lander drop softly. But it couldn't process the data correctly. Instead of turning off the rocket for a smooth landing, it kept firing. The result? Surveyor hit the surface, bounced, and actually flew 11 meters back into the air. The lander came back down with its engine still firing and bounced off the lunar surface a second time. On the third descent, it either finally realized how close it was or just ran out of fuel. Either way, the engine shut off and the spacecraft finally settled on the ground. Surveyor 3 had drifted so far during the bounces that it ended up resting on a sloped edge of a big crater. Despite that rocky landing, the mission was considered a success. And this brings up a question people ask a lot.
How did NASA manage to land on the moon almost 60 years ago using computers no more powerful than a calculator? Yet today, with all our advanced tech, we still struggle. Part of it could be that we tend to look at the past with rose-colored glasses. We often confuse good fortune with great engineering. It's also true that today's missions are held to higher standards because we expect more. To be fair, not every modern landing attempt has failed, but many of them have. Take iSpace again, for example. Their 2025 crash wasn't their first. They also had a failed landing back in 2023, though for a different reason. That time, the laser system did its job, but the spacecraft's software misread the situation. And once again, the issue came down to altitude. The lander believed it was just above the surface and shut off its main engine to land gently. But in reality, it was still 5 kilometers in the air. The spacecraft dropped like a stone. It almost seems like measuring distance on the moon is trickier than it should be. Strange, isn't it? No matter how advanced the computer is, it still struggles when it comes to certain lunar challenges. Another failed mission in 2025 might shed more light on this. This time it involved an American company, Intuitive Machines. Like iSpace, they were attempting a second moon landing, also using a laser system to guide the descent. Their lander ended up tipped over at the bottom of a crater near the moon's south pole. It didn't fall because of its fridge-like shape, although that probably didn't help, but because it came in too fast, with too much horizontal speed. Instead of just dropping straight down, it was also moving sideways. So when it hit the ground, it tumbled over a few times before finally stopping. Once again, the lander system didn't have an accurate idea of how high up it really was. Later on, the CEO of Intuitive Machines explained that the laser altimeter had problems with signal and noise distortion, which meant it couldn't measure altitude correctly. So here we have two different companies, both in 2025, both using different spacecraft, and yet both ended up with almost the same issue. That might point to a larger pattern, something about the moon itself that keeps confusing robotic landers. Or maybe not. After all, as some people like to remind us, there have been also many successful lunar landings. Yes, we've even sent astronauts to the moon, but that was a different story. The Apollo missions had automatic systems too, but they were extremely basic. So NASA's backup plan was simple: give the astronauts full control. If the computers failed, the humans could take over. And to prepare for that, every Apollo lunar module pilot trained on Earth using a full-size, rocket-powered simulator. That machine was risky. It almost cost Neil Armstrong his life. But despite the danger, NASA believed it was absolutely necessary for astronauts to know how to control their landers manually without depending on computers. And in the end, that approach paid off. Every Apollo mission made it safely to the moon. They didn't always land exactly where planned, but they never bounced around or crashed either. So basically, there are two ways we've used to land on the moon. One is trusting skilled humans with sharp senses and quick thinking. The other is relying on computers packed with sensors and data tools.
In theory, the second method should be more reliable. Machines don't get tired, distracted, or make emotional decisions. Everything is based on math and logic. No room for human mistakes, right? But the truth is, even these advanced systems mess up. And what's worse, they keep making the same mistakes. It's like they don't really learn from what went wrong the last time. A big part of the problem? The moon itself. It doesn't behave like we expect. For something so close to Earth, it's still full of surprises. We keep trying to use Earth-based technology there, assuming it will work the same way, but it often doesn't. That's why missions with human pilots have been more successful. Sure, humans aren't perfect, but we can adapt. When something unexpected happens, we adjust, we troubleshoot, and we come up with solutions on the fly. And that kind of flexible thinking is probably the key to mastering lunar landings, even if we eventually leave people out of the cockpit. 2025 has been a major year for lunar missions, and while failure teaches us a lot, so does success. In March, a lander called Blue Ghost, built by Firefly, managed to reach the moon in one piece, and it did so using a very different approach. Like other landers, it had the usual computers and sensors, but it also came with something new, an artificial intelligence system that helped it navigate. Think of it like this. When Neil Armstrong landed on the moon, he didn't rely only on instruments. He used his eyes, instincts, and flight training to guide the module safely down. Blue Ghost AI worked in a similar way. The system had data on altitude and speed, just like any flight computer, but instead of blindly trusting the numbers, it made decisions based on what it could see through its cameras. Those cameras were like its eyes. The AI scanned the surface, picked out a safe spot, and guided the lander there based on visual input, just like a real pilot would. And it wasn't just reacting in the moment. It had been trained with tons of examples. It had seen different landing situations, learned what went wrong in the past, studied what worked, and used all that knowledge to respond in real time, no matter what surprises the moon threw at it. This kind of technology is still new to space missions, but we've already been using it here on Earth for a while. Think about self-driving cars from companies like Waymo, Cruise, or Tesla. In fact, Tesla is well known for designing its cars to rely heavily on cameras and artificial intelligence, very similar to what Blue Ghost did. There was a time when Tesla cars used radar and sonar sensors to give precise real-world data to their AI systems. But now, Tesla has switched to relying only on cameras. What many people don't realize, though, is that Tesla still uses traditional tools like LiDAR, a mix of laser and radar tech. There are plenty of photos showing Tesla vehicles equipped with LiDAR units, which help train and fine-tune their camera systems. If this camera-only method works well, Tesla could quickly roll out self-driving cars on a massive scale. But there's still a catch. When the AI gets confused and doesn't have backup measurements, the car can make strange or even risky decisions suddenly. This is a big challenge that could slow down their progress. Similarly, with Waymo, Google's self-driving car project, people often think they don't use cameras or AI because of the large spinning sensor on the roof. But that's not true. Google is a leader in AI, and Waymo actually combines AI vision with data from LiDAR, radar, and sonar sensors. This mixed approach has helped them get ahead in the driverless taxi business because it's more reliable, blending advanced AI with proven tech. This blend of technologies gives the best of both worlds, and it's an approach that could be very useful in space exploration too. Sometimes people get stuck trying to copy the past instead of embracing new technology. It also shows how slow the space industry can be. Most of the new spacecraft weren't designed with today's AI in mind. They were planned years ago, before these advanced algorithms existed. The companies behind them often resist quick changes, focusing more on investors and shareholders than on adapting fast. If you listen to leaders at iSpace and Intuitive Machines, you'll hear a lot about business success even as their landers lie broken on the moon. That kind of attitude can seem crazy. Meanwhile, Firefly, a private company more focused on getting results than money, is pushing the limits of technology and actually succeeding. Of course, Firefly is planning to go public this year, so things might change again. And once more, we might be mixing up luck with good engineering. But so far, out of 3 recent moon landings, 2 failed and 1 succeeded using a different strategy. What do you think about that?